Hello everyone. In this YouTube video, we are going to solve an interesting Leetcode problem asked by Google, Meta and Microsoft called as Robot Room Cleaner. So in this problem, there is a room represented by an M cross N binary grid where 0 represents a wall and 1 represents an empty slot. So in this room, we have a robot present at an unknown location somewhere. A robot can be represented by its location and the direction the robot is facing in the room. Now, our task here is to use the robot to clean the entire room. Now, a robot can do 4 actions, which is represented by this robot interface. It can move in one direction. It can move one unit in the direction it is facing. It can either turn left or turn right, or it can clean the current cell the robot is present at. Note that we do not know the initial location of the robot, but we do know that the robot is facing up and all the edges of the grid are considered to be a wall. Now let's think, how would we solve this problem if the grid was given to us? So this is the grid, these are the walls, these are empty cells, and here is the initial location of the robot, and the robot is facing up. So we move in the direction the robot is facing, then we again try to move in the direction the robot is facing, but we are hit by a wall, so we turn right and go one step in that direction. Now we again try to move in the same direction, but there is a wall, so we turn right and we move one step in that direction. Then we again try to move one step in the direction, and then when we again try to move, there is a wall, so we turn right and move by 1 unit in the direction. We again try to move 1 unit in the direction. When we again try to move, we are hit by a wall, so we turn right and we move by 1 unit. We move in the same direction by 1 unit. We try to move in the same direction by 1 unit, but we are hit by a wall. We turn right, the location is visited. We turn right, the location is again visited. We turn right and try to move 1 unit in the direction. We again try to move 1 unit in the same direction. We turn right and hit by a wall. We turn right and the location is visited. We turn right and try to move by 1 unit in that direction. We try to move 1 unit in the same direction. When we try to move in the same direction, we are hit by a wall. We turn right, we are hit by a wall. We turn right, the above cell is visited. We turn right, we are hit by a wall. So now we have visited all the 4 directions of the cell, so we backtrack. Then again we turn right, we are hit by a wall. We turn right, the above cell is visited. We turn right and try to move by 1 unit in the direction. Now we try to move again by in the same direction 1 unit. The cell is visited. We turn right and try to move. We are hit by a wall. We turn right, the cell is visited. We turn right, the cell is visited. So we backtrack. We turn right. The cell is already visited. So we have moved the 4 directions. We try to backtrack. All the 4 directions are already visited. So we again backtrack. Again all 4 are visited. So we backtrack here. So 4 are visited. So we backtrack. These 4 are also visited. We kind of backtrack. These 4 are not possible to visit, so we backtrack. Over here, now we take a turn right, and then the previous location is visited. We take a turn right, the previous location is visited. We again turn right and we move 1 unit in this direction. We again move 1 unit in the same direction, and then we turn right and try to move in this direction. We move in the same direction by 1 unit, we move the same direction by 1 unit. We turn right, we face by a wall. Turn right, where this is already visited. Turn right, we are faced by a wall. We backtrack by 1 unit, we come here, and then we turn right, we are faced by a wall. We turn right, this location is visited. We turn right, there is a wall, so we backtrack by this. Then when we come here, we turn right, the above is visited. Then we turn right and move by 1 unit in this direction. Similarly, we traverse this entire path and we backtrack to this location. All 4 locations are visited. We come here again, and then we come to this backtrack to this cell, and then we turn right. This is visited. We turn right. This is visited. We turn right. We move to this cell by 1 unit, and then we move in the same direction. We move in the same direction. We turn right. There's a wall. We turn right. There is a is visited, so we again turn right and move in this direction. We move in this direction. Turn right, there is a wall. Turn right, there is a wall. So we turn right and move in this direction. And then we turn right wall, and again turn right. There is cell is visited. We again turn right and come back here. So now we will again backtrack from here because all the four locations are visited. We will backtrack from here. We will move to this cell and then we backtrack to this location, to this location, to this location, and then we again come back at our starting location. So a few interesting things to notice is that the robot ends its traversal in the same location where it started from. Starting location is equals to ending location. And then now let's try to understand, build the intuition if the grid was not present to us. So let's say uh, if the robot is present here facing up, we try to move to the next direction in the same direction the robot is facing. If it's possible to move, if the cell is not visited, and if there is not a wall, we move in that direction. So we need to basically maintain the visited. Mm, we need to store the cells that are already visited by the robot so that we do not go back to them again. So now if there is we try to move in the same direction, but if there is a wall, we turn right and they move to this direction. We move to this next unit, next cell. Then there is a wall. So let's say if there is a wall, not possible, and if we are not possible to move, then we turn right by this. If it's possible to move in the same direction, we do move it. If there is a wall, we turn right and then we reach here. And then again, if it's not possible to reach here, we will reach to the initial location. So this is the basic intuition. If it is possible to move in the same direction, go in that direction. Otherwise, take a turn right and do until we exhaust all the four directions for that location. And if we have exhausted, backtrack to the previous location and take the next possible direction. So this is a basic intuition. Now, one interesting thing to understand is that the initial location of the robot is not given to us. But let's think for a moment if we really need to know that location. So if this current location, let's say, is 2 comma 2, then this location above it would become 2 comma 1. So the next location or any location in the path of this robot is relative to the initial location of the robot. So this means that this exact location we do not need to know. So we can safely assume the initial location of the robot to be 0 comma 0. Now let's look at the code. So here we are maintaining a visited set. So basically we will be maintaining the locations that are already visited by the robot. And then these are the four directions. So whenever we are moving up, our basically row number will be decreased by 1 and column will remain unaffected. And when we go down, the row is increased by 1. When we move to the left or right, column is decreased and increased by 1 respectively, and row remains unchanged. These are the four directions, and then we have a directions vector which consists of these four different pair of, and then these directions are represented in the clockwise order. So let's say when we're facing the up direction, when we move right to turn right, we go to the right direction. When we turn right, we go to the down direction, and when we turn right, we go to the left direction. So these directions are arranged in the clockwise order. We will understand why it is like that. And then this is the clean room function. That is the entry point in this code. We have a robot. So when we start the traversal, we need to know three things. First is the current location of the robot. So as explained previously, we can safely assume it to be 0, 0. Then second is this is basically represents the index in the directions vector, which basically represents the current direction of the robot. as the robot is initially facing in the upward direction, the initial direction index value is 0 over here, and the robot interface itself. Now, when we traverse the mm, when we start our traversal, first we call the first the robot cleans the location, and then we insert this current position in the visited vector, and then we look at all the nearby 4 cells. So starting from the cell which is in the same direction as the robot. So initially the value of I is 0 and direction of index is the direction of the robot. So the next direction index is basically the same as direction of the index. So we are trying to go in the same direction the robot is facing. So this way we call get next position to get the position of the next cell which is in the same direction as the robot is facing. Then we check if the next position is not being visited and the robot is able to move. So basically it's not a wall. Then we start the traversal in that direction. So we pass the next position, the next direction index and the robot. So if even if the cell is visited or robot is not able to move because of a wall, we make the robot turn right and then we check our next direction. So when we turn right, so this is the logic when we turn right, and that's why these directions are arranged in the clockwise order. So whenever we turn right, so if the initial location was up and we turn right, the next right location is the right. After all the 4 locations are visited, we kind of go back to the previous cell basically. So basically, if we are at this location, we try to move with the same location. We come back, then we try next direction, and this is the 4th direction. So after all the 4 traverses, we notice that the robot is at the same location and facing the same direction. So now if you want to traverse to the if you want to roll back and we go to the previous location, what we need to do is basically we just need to move by 180 degree, move to the previous location, and then again move by 180 degree. So if the robot is here right now, its previous location would be this, and direction would also be in the same direction. So in order to go from here to here, we call this function go back, and we turn left twice to face in the opposite direction, move, and then we call robot move to the location, and then again change the direction by 180 degree. So this way, this is basically the previous state of the robot from this state. So we call this go back function. So we go to the previous state of the robot, and then we check basically the next direction. So for this robot, it will turn right and we will go somewhere over here. It's possible to go. When it is visited all, it's possible to visit over here. We will try to go right and go over everywhere over here, and then go right. So this way, this will complete all the traversal. Let's look at the space and time complexity. So this is a normal DFS graph traversal. So over here, complexity would be order of V plus E, um, where V is number of vertices and E is number of edges. So over here, number of vertices is let's say n, like number of cells in the grid, and edges will be 4 times n. So overall, the time complexity is order of n. Um, and if we look at the space complexity, so we are using this set. So in which also number of maximum like visited cells can be the all the cells of the grid, and so that way which is n, so the maximum space complexity can also or can go till n, which is order of n. So with this we are at the end of the video. If you like the video, please like and subscribe, and see you in the next one.